Welcome! In this lesson, we build an intuitive, layered picture of how the lithosphere deforms in mountain belts. We'll move from brittle faulting and folding near the surface to ductile flow at depth, and then to whole plate behaviors like flexure and lithospheric removal. First, the lithosphere is rheologically layered. The shallow upper crust is mostly brittle, while the deeper crust and upper mantle are warmer and deform ductily. Think of a brittle cap over a flow-capable interior. Let's sketch a simple cross-section to anchor this idea. Temperature and depth push rocks from frictional failure into viscous flow. Near the surface, brittle failure dominates. Three end members are common: thrust faults in compression, normal faults in extension, and strike-slip faults in lateral shear. We'll show each in a simple panel, then add folding driven by shortening. In many mountain belts, weak layers like salt or shale act as detachments. Above them, thin-skinned fold-thrust belts develop. Let's sketch a thin-skinned belt detached along a basal horizon. Then, sometimes deformation steps into the basement. Thick-skinned uplifts form. We will add a basement fault and uplift block to see the contrast. Below the brittle ductile transition, strain localizes into ductile shear zones and broad flow. Think of lower crust that can slowly flow, thickening and redistributing mass. Will represent a shear zone band with stretching lineations and flow arrows. If a weak middle crust forms a channel, material can be squeezed outward between a strong top and bottom. At the base, thrusting accommodates convergence. At the top, normal faults relieve gravitational stresses. Arrows show outward flow within the channel. On long wavelengths, the lithosphere bends elastically under loads. Mountains push down, and the foreland flexes, creating a basin that fills with sediments. Watch the loaded beam sag next to the range and a foreland basin develop.